Hello, and thank you for listening to our group's presentation today on bias in statistics. Here with me are my colleagues Bikram and Eric. My name is Liam, and it's a pleasure to be here to present. Let's get started. To begin our presentation, we wanted to answer the question, what is unconscious bias? The definition that made the most sense to us was on the Vanderbilt University page for Equity, Diversity, and Inclusion, and is as follows. Unconscious bias or implicit bias is often defined as prejudice or unsupported judgments in favor of or against one thing, person, or group as compared to another in a way that is usually considered unfair. In contrast, deliberate prejudices are defined as conscious biases or explicit bias. One of the most common unconscious bias in today is that women are weak. This statement is inherently incorrect. Many women are gifted athletes. An example of this is Serena Williams, one of, if not, the most dominant athlete the sport of tennis has ever seen. By no means is this individual weak, and in fact Serena is stronger and more athletically capable than most men her age. The only true way to combat unconscious bias is through education and experience. When the individual is not conscious of these misguided thoughts, it is impossible for them to think otherwise. The individual must take it upon themselves. The need to grow and evolve is necessary for unconscious bias to be eliminated. The following is a list of bias avoidance tactics that can be used in combating bias at a foundational level. Using an alternative perspective is important because it allows us a third person's point of view and can help us think more objectively and fair. Choosing words carefully is always important when addressing another person or group. Avoiding generalizations is equally as vital, as it is never good to speak in absolutes. Providing evidence and sources helps avoid assumptions, and lastly, just to be as sensitive, objective, and self-aware as possible is the best way to avoid our own bias. The following is a list of examples of bias in statistics, and these are the concepts we'll be going over in our presentation. Selection bias, sampling bias, time interval bias, susceptibility bias, confirmation bias, survivorship bias, recall bias, observer bias, omitted variable bias, causation bias, and funding bias. Now moving forward, Bikram's going to be going over selection bias for us.
In the next few slides, we will discuss what are the different types of bias, which will give you an understanding on what they are and how you can avoid them. Let's start with the selection bias. In this type of bias, there is no proper randomization of the sample. That means that the sample that the researcher has chosen for the research is not representative of the population, which is the basic criteria for any research. Now, there are different types of selection bias. The first one is the sampling bias. As discussed and as shown in the image, in this, the data used is not representative of the entire population. The next is the time interval bias. As the name suggests, in this, the researcher will choose a certain time frame or a certain range of time, which will then lead to results which will give desired conclusion. As shown in the image, the researcher chose the period of 9 to 12 in the morning, which has the highest number of tweets in the hour. Thus, when they average it out, it will show that the tweets average was higher than normal. The next is a susceptibility bias. Now, this is very common in scientific, clinical, and epidemiological research. This is basically an idea of mixing up the cause and effect correlation. In this, the researcher cannot uh, clearly demarcate between the cause and effect relationship. The last type is the confirmation bias. In this, there is a tendency of the researcher to favor information or results that conforms to his or her belief. That means the researcher will deviate away from the facts and go with the conclusion that is more close to his or her belief. The next type of bias is the survivorship bias. In this, the researcher only takes into consideration the surviving group or the successful group. That means the group which did not survive or wasn't successful is avoided by the researcher. Thus, the data is not representative of the entire population. Let me explain this further by taking the example of the image below. In the pyramid, you can see that 0.1% of individuals succeeded, while 99.9% individuals failed. If the researcher only selects the sample from the successful group, that is 0.1%, the result will not be applicable to the entire population, and thus the research is biased. The next type of bias is a recall bias. This is a very common bias which is observed in interviewer survey situations. This clearly means that during the study, the respondents or the sample group do not remember things clearly. Now, we cannot conclude that the individual selected for the particular type of research had good or bad memory, but it is about the selective memory or the selective retention of certain aspects which are to be used in the research by the individual participating in the study. The next is the observer bias. In this, the observers or the ones which have been called to observe a certain situation or a scenario already know about the end results, and based on their knowledge they will influence the observation or the results of the study.
Hello, my name is Eric Toledo, and I'm going to be speaking a little bit more about statistic biases. So one of them I'm going to talk about is omitted variable biases. So the omitted variable bias is a type of selection bias that occurs in regression analysis when we don't include the right controls or excluding a relevant variable or underspecifying the model. So let me provide an example. Say for you to be academically successful, one of the biggest factors is for you to have a lot of books. Yes, that is one relevant factor. But what about the other factors? For example, your parents having a high IQ. So if you omit this variable, then it will disconsider that your parents having a high IQ is not relevant to academic success. So basically, it is omitting a relevant factor and emphasizing on only one factor, and that is what is omitted variable bias. Okay, so the next bias I'm going to be speaking of is the causation bias, also known as the cause and effect bias. So what is the causation bias? Causation bias is the belief that there is causal connection between two events that are unrelated. So it comes from the word causation and correlation. So a quick example to be understood is that on a dry, hot, and sunny summer weather, a lot of people like to eat ice cream, so that's a cause. And also on a dry, hot, and sunny summer weather, people will have a sunburn, so that's a cause. But then some people will say, every time I get a sunburn, it's because I have an ice cream. But that's not a cause, that's a correlation because it's a dry, hot, and sunny summer weather. So that is basically what the causation bias is. Okay, so moving on to our final bias, it is the funding bias. So what is the funding bias? The funding bias is a statistical bias, and it happens when the result of a scientific study is biased in a way that it supports the sponsor of the researcher financially. So a good example to give was an article back in 2013 where it said the soda industry sponsored studies found to be 5 times more likely to conclude soft drink consumption is unrelated to obesity. So you can clearly see that soft drinks are correlated to obesity, and the company funded that research in order to make it seem like uh, obesity is not related at all to the consumption of soft drinks.